Hope everyone is doing all right. Hope you are doing pretty well as well. Yeah, it's Hadyr Koumakpai. You said it right. Um, let me start first of all by sharing my slide. Okay, not sure if you can see it properly.
I'm not seeing it yet.
Okay, hold on. Okay, here we go.
There we go. It's starting to share. There we go. Thank you. Well, over to you then.
Okay, perfect. Well, I'm going to touch base quickly on some technologies and understanding that the market is very keen on understanding where we stand, where we're talking about the new technology, because people have been seeing 400, 600 watts, and soon they will be here, maybe 700, who knows. So, I mean, it's good to put a bit of clarity on where we stand and what is happening at the moment in the market. Um, well, I should say, first of all, again, it's a pleasure for me to take part to this webinar. And I will try to make it short, simple, and understanding that the audience is not all solar specialists. And some companies are also starting exploring a venture in this industry. So um, yeah, it's quite important to show the global intensive growth of the solar installation 10 years back to date, based on the Becquerel Institute, in 2019, the total installed capacity was close to 627 gigawatts, which had easily doubled the capacity installed in 2016. In 3 years' time, I could say that there's quite an evidence, when you look at the curve, and it's a good reason for a company to be involved in this dynamic industry. From 2009 all the way to 2019, that's the massive increase. From 23 gigawatt, now we are standing on 627 gigawatt, which is quite massive. However, there are some key leading countries like China, which are above, let's say, 200 gigawatt installed in 2019, followed by US, Japan, Germany, and India. And the rest of the world cumulative has installed a total of capacity lower than China has done, and keeping in mind that Africa in total in 2019 has installed around 5 gigawatts approximately, which represents 2.41% in the total of the rest of the world. Where you consider that the rest of the world has installed lower than China, and then we just installed 2.4, 2.5% of what the total of the rest of the world has done. We still have some way to go. However, there are quite some interesting countries which need to be looked at. In the continent, we still have a very promising solar market coming in the next coming years. We have some attractive countries such as Egypt, South Africa as well, which is one of the main leading market when it comes to solar in the continent. Algeria, Kenya, Senegal, Morocco, Tunisia, just to name those countries. And normally where we're talking about the need of the power, that could basically justify the market attractiveness. But in our case, there are many factors to be considered, such as the political stability of the country, the regulatory frameworks, and we just have NESA, which gives us a lot of information about those situations in South Africa. The security risk, the currency fluctuation. South Africa does last, especially because of the virus, you can see a lot of change of the currency, which has put a lot of project into some challenging position. And that affects a lot in when we're talking about project bankability. The reason why you could see a country like DRC and other countries, despite their massive need, are not quite attractive. Because they are not among the most attractive solar investment countries, just because of many factors, such as what we said, the currency fluctuation, the political stability, as well as the country security risk, which is quite high. Talking about that, let me just give you, when we're talking about investment, investment goes every time with risk. And most of the solar players, either DFIs, IPPs, EPCs, or off-takers, are quite specific about mitigating the risk in the project. Out of the general risk, which might be related to the general investments such as liquidity, the forest fluctuation, and guarantees, come the risk of equipment performance, where we, JS Solar, plays a key role. Welcome to the reliable solar module in the industry. We all might have different meaning about bankability, but for what is sure, the solar module bankability as a product is related to the reliability of the product, to be able to perform according to the expectation during its life cycle. And when it comes to a company, it's related to the sustainability of the company, which are defined by its financial situations, its stories, and the company business model. Let me take you a bit through JS Solar. It was a company established in 2005. In 2019, it had a total revenue of $3 billion US, with more than 22,000 employees, 12 global manufacturer base, and has been the second largest solar module supplier for the last 2-3 years. As a global leading of the PV industry, JS Solar is a vertically integrated company, from the ingots, wafer to cells, and all the way to module manufacture. And you can see from the graphic that the company has been growing exponentially years after year, with the shipments all across the world: Japan, Europe, US, India, Asia, Middle East, and Africa, where we are also quite present. As I was saying, for 8 years consecutive, JS Solar has been the world leading cells manufacturer. We also has been one of the first holder of the PERC patent in the industry, the first adopter of the double print technology in mass production, the first company to acquire the IP right when it comes to usage of the gallium dope technology. When we're talking about the gallium dope technology, a lot of people don't get it right. Let me tell you, it's quite obvious that companies sometimes can come to you and point out the numbers of the degradation of the panel over the year. But I mean, at the moment, without the gallium dope technology patent, I don't understand how they can do that. The advantage of the gallium dope technology is purely based on improving the solar cells performance, reducing the LID, having a positive effect on the LITD on the solar module, and reduce the degradation of the solar module. Let's say, instead of 2.5 to 3% on the first year degradation, you have below 2% degradation for the first year. And on a single glass, you have 0.55% per year. And when it comes to the bifacial double glass, you have 0.45% per year. Out of that, there are numbers of precaution, treatment, testing, done during all the production and the packaging process to mitigate the common risk, such as the soiling, the delamination, and the sales crack, which has affected a lot of projects so far. Many companies doesn't pay attention so much on how are the package of the product, which is very, very critical. I mean, everybody would like to load a lot of panels in a container to reduce the shipping cost. But the question is not about reducing the shipping cost only, but only it's also about how we care about the packaging to make sure that the product arrive on the site without major macro crack on the product, especially that we know the road in Africa in general are not the best. Well, we have some countries with a perfect road, but that doesn't apply for all the countries. Well, from 2009 all the way to now, you can see a massive increase of the solar module output from 2,290 watts all the way to 545 plus watts. And we are 100% involved in all type of technology, from half cut cells, which has better performance under the shading condition, to multi-bus bar round ribbon, which increase the module performance by its better light absorption. And of course, the bifacial with its excellent temperature coefficient, about 3 to 15% extra gain according to the albedo. Putting in mind that JS Solar has been a pioneer of those technology. Allow me to show you a couple of products and their relative cell size. It is important to understand that different improvement of the cell's efficiency and the age of the wafer size and to increase the power output of the module. In less than 2 years, we have seen a rapid shift from G1 to M6 to M10, and soon, I mean, we will be there on M12. But it's quite important to understand that the technology behind 400 plus watts or 500 plus watts are relatively the same. The only difference is the wafer size, the numbers of bus bar, and the numbers of cells on the panels. We also understand the need of companies require for the higher wattage module as possible. And we have seen in some cases that the higher wattage is not necessarily the best option. So it's vital to understand that bigger module do not necessarily mean best performing module. You might have a bigger module which doesn't, let's say, impact positively on your solar plant. So it's important to make that study and to select the right one. Obviously, the customer expectation and requirement is also one of the key booster toward the race of the higher module. But still, we should not get away from the performance factor or the backability factor of the product. Again, when we take 545 plus watts, that do not cancel, in any case, it do not cancel the 540 watt module, and also the 550 watt module do not cancel the 400 plus watt module. I mean, each of them should be taken separately and considered case by case. Just for example, it is just, it's easy to just put together 78 cells, or maybe, who knows, in the future, 84 cells to reach 600 plus watts. That is quite impressive, right? When you hear the number 600 plus 700 watts, is impressive. But the question is, will that still be a reliable or bankable product? I mean, what will be the challenge in the transportation or installation of 2.5 plus square meter solar module? Understanding that to carry the module, you need to care about how many workers are allowed to carry some module. Because when we go above 25 kilograms, it's important to have at least 2 workers carry 1 module. I'm trying to just imagine, right? I think the industry players can tell us better what will be the perfect type of module, because we try also to serve as long as we can. Another key factor of the solar module is the efficiency. It is related not only to the cell's efficiency, but also to the size of the module. Let me give you a clear picture. As one of the technology we have in-house and still working on for the best treatment for it is the tiling technology. As I was saying, with the M6 wafer 158.75 millimeter, if we align the cells the same way we do with the G1 wafer 166 millimeter, the size of the panel will be super large, especially with the 78 cells. And also the efficiency of the panel will be affected, whether we want or not. Then, by reducing the size, the space between the cells or tiling them one on other, it will help to reduce the entire size of the solar module, but the size of the cell is still the same. Then when you reduce the size of the module, you can increase the efficiency of the module while the cell's efficiency on the module is still the same. But there are numbers of concern need to be considered and addressed. You can see from the tiling that you have around 0.5 millimeter of the cells, which is covered. And we all know when a part of the cell is covered during a long period of time, it might create a hotspot. That is the general knowledge, which is one of the risks. The non-exposure of all the entire cell surface to the irradiation could reduce the nominal power output and increase the CTM loss of the cells. The bifaciality percentage of the product will definitely be affected as well. Saying all that, the tiling is still a very good technology that you need to be followed. And as a company, we are working on it. And JSolar will officially launch it when we're sure that all mentioned concerns that I have listed has been properly addressed to the industry. Therefore, I will invite the industry player to look at the practical points of view of large module and to keep a close eyes to the technology and the treatment and the technology and treatment behind the solar module assembly. Focus sometime more on the LCOE when it comes to the IPP investment, and to compare the balance of system, including the installation costs, logistic, operation, and maintenance costs, of course. Just to sum up, you can consider the 400 plus watts. That is a best product, when you come to reduce the CapEx, and it can come up with a very competitive price. When you take the 450 watts range plus, that had a better balance of system, especially when you use the 2P tracker, and also provide a good LCOE. While with the 545 plus range is the best option for a 1P tracker, a good LCOE as well, and less terrain risk as a product. All things considered, as I said, I promise to not take too long time. I believe that there are more questions that participants would like to get more information about. And also, I'm very open to give to address any question that you have and any question that a participant have. Thank you for all and thank you for your attention.
Thank you very much, Hadyr. I just wanted to check with you, when is it going to end? Because the progression of module efficiency has grown so fast, and it actually influences some people to say, well, should I buy now or should I wait a year and buy the newest technology in a year's time? Or how would you see that? Should people just continue buying, install now and replace modules in 10 years perhaps, and not wait out to 25 years? How do you see that longevity, or if we think of the LCOEs that we calculate on a day one for a 25-year, should you, due to the fact that the evolution is so quick, rather consider module replacement during the lifetime of a project?
Good question. One thing is to say that each project has a timing, and when the project has a COD timing to meet, in that case, sometimes you just need to go with the flow of the market. But again, as I was saying, at the moment, you know, the cells itself has a limitation in terms of efficiency. And obviously, we believe that the efficiency of the cells in the next, let's say maximum of 5 years will stop there. But, you know, the solar panels improvement cannot end so soon, because it's a quite dynamic market where you should not forget, it's quite competitive market where we can see at least the top 7 are quite aggressive. So each company trying to find the right way to be able to position the cells to increase the efficiency of the panels. Obviously, personally, I don't think it's something which is going to end soon. As long as there's still research and development going on in the markets. So we believe that in the next coming years, because look, now we are on the M10, M12 is for soon, and the speed behind that is quite fast, because when we start the year, let's say in 2019, when we start the year, we were still talking about 375 watts as one of the top wattage in the industry. But before the end of the year, we have in a quite short time moved to 385, 390, 405, 410, and now before the end of the year, we already reached 440. So that speed is quite quick. And this year already, we started the year with 390 as a mainstream and 400, 405, 410 as the second, as a top type of module. But we already ending the year with 600, let's say with 545 wattage promoting in the industry. So, well, as long as the industry are dynamic, I think there will still be improvement in the cells, in the treatment, and in many things. Putting in mind that we are talking about the P-type, N-type is coming up from next year, and I think that will be another massive increase of efficiency of the cells as well as efficiency of the module.
Right, yeah, it's interesting to track the quick advancement, but also the quality. I mean, we could track on the large manufacturers the quality of modules coming out of there and the quality that we see in generation of these, and that's actually performed on that REN 21 report that you showed us, the uptake, how volume has driven quality and price, and yeah, it's great to see there. Thank you very much for your participation today. I think there's a few questions that was posed on the group chat. It was actually more to Dennis. Dennis, I'm not sure if you are available. I know you are on the call still, but whether you want to are able to answer them. I could perhaps address one of them. Someone asked, what's the current regulations, Victor M asked, what's the current regulations around the cross feed of electricity across property boundaries? Dennis, I'll unmute you, but I'll start addressing that what I understand of that, and perhaps you could fill in. But as far as I understand, that is only allowed through distribution license holders. And that's why you have a distribution license, is for those distributors then to distribute power. And even if you transfer property from you to your neighbor, that would amount to distribution. It seems I'm having trouble in unmuting Dennis there.